Okay, in your class yesterday, we left off with graphing these square root functions, and we'd hit those that they involved lots of different pieces, right? So I think we're just going to jump right into B, and I'll kind of recap as we go through B here. As we look at B, it's y equals 3 times the square root of x plus 2 minus 4. Talk about the pieces with me.
And we'll go on the left 2.
Okay, Dayton says left 2. Agree? Disagree?
Agree.
When it's in the radical, left or right, opposite the sign. So left 2, okay.
And I'll put down 4.
Down 4 because at the end, you add or subtract. When it's adding or subtracting, you go up or down with the sign. You guys save the best for last. A stretch of 3. And specifically, I'm going to remind us that it is a vertical stretch of 3. Okay. So this graph has to go left 2, down 4. That's a piece of cake, right? You guys learned to count a long time ago. And you know your left from your right, yes? That's the other challenge. Debatable sometimes, right? Okay. Well, that is a required skill for this graphing, left versus right. Okay. Now, the stretch. A vertical stretch affects x or y values. The y values, right? So if you recall from what I suggested yesterday, we take the y values from our original xy chart and multiply them by 3. Now, we don't have a reflection to worry about this time. So I'm actually going to write this step down so you have the visual to see it. So I'm going to start with my xy chart. Do you remember that basic square root of x xy chart from yesterday?
0, 1, 4, 9 for x, and then y is 0, 1, 2, 3.
Okay. 0, 1, 4, 9 are my x values because those are the numbers I can take a nice square root of, right? Those are my perfect squares. And their results are 0, 1, 2, 3. Now, we're going to keep those x values, right? Those are good. We're not going to change those. But because it's a vertical stretch, we're going to take every y value and do what? Multiply by 3. So, I like to write this down. 0 times 3 is 0. 1 times 3. 2 times 3. 3 times 3. Challenging math there, I know. Sorry, I guess I'm feeling sarcastic today. Or extra sarcastic. So, we're going to graph these points right here. And then after we graph those points, then what are we going to do? Yeah, then we will take each of those points and move left 2, down 4. Okay. So, start graphing the points. And let's see, I think, okay. So, instead of 0, 0, we're doing 0, 0. Instead of 1, 1, we're now going to do 1, 3. Instead of 4, 2, 4, 6. Instead of 9, 3, 9, 9. Okay. I have those points graphed. I'm going to take each of those points and go left 2, down 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. One thing I would be careful of, I use two different colors. I don't know if you guys can tell it, but make sure you connect the correct dots, yes? It would be easy to, although that 0, 0 kind of ends up in there. Okay. Why does this have a slightly different shape from our other graphs? Because it's a stretch, right? That stretch pulls the y values up. So it's going to make it appear taller, so to speak. It's stretching it up. Okay, got it? Okay, so if you look at example 4, first of all, it does say graphing a cube root function. Yeah. So we're going to graph cube roots instead of square roots. Now, I told you yesterday that I was going to change and give us simpler ones to work with. Because is a square root and a cube root graph going to look the same to begin with? No. So we've got to kind of start over. Okay, the square root graph is more my focus, but it's good to think about the cube root graph. So on A, we are just going to graph the cube root of x. We've got to know what this looks like. And of course, if you don't know what the graph looks like, just like yesterday, what am I going to suggest? An XY chart. Okay. We need values. Do we want to use our same values from our square root chart? No, because, now some of them might be the same, obviously, but if we use the exact same values, we want values we can take the cube root of this time. Not square root, but cube root. So, is 0 still good? Yeah, we like 0. The cube root of 0 is 0. Is 1 still good? You can do any root of 1. What's the cube root of 1? 1. What's the next value we want? 8. Because the first number you can truly take the cube root of after 1 is 8. The cube root of 8 is 2. And I gave myself away, didn't I?
Yeah, you did.
What did I give away? Do we need to think negatives this time? Yes, if you don't think negatives, you're going to lose half your graph, which is important, okay? So, what's the cube root of negative 1? Negative 1. What's the cube root of negative 8? Negative 2. So remember, the cube root of a positive is a positive. The cube root of a negative is a negative. Okay, let's graph these. Negative 8, negative 2. So I'm going to go left 8, down 2. Negative 1, left 1, down 1. 0, 0. Right 1, up 1. Right 8, up 2. Any thoughts on what this shape might remind you of? Okay. Yeah, you guys have seen. This is a variation of x to the cubed, right? X to the third. X to the third is normally a vertical version of this. It starts low, kind of jogs at the center, and goes up. Well, the cube root of x is the inverse, which means kind of like, instead of a right side up parabola being a sideways parabola, this is a right side up cube, goes sideways. And so it is the same graph, just sideways. Kind of jog through there, through the center there, and looks something like that. I mean, if we wanted to go another set of ordered pairs out, the next perfect cube we know is 27. Yeah, we'd have to go 27.3 to go farther. Yes. Yes. Good, valid point. This one goes all the way through on both sides. Yes, we want arrows on both sides. Okay, this is extended. And the difference is we can use positives and negatives, right? So that's the difference. Okay. B, I tried to make easy. Just get you guys the basics. Y equals the cube root of x minus 5. What do you know? Take the graph we just drew and move it down 5. You got it. Again, just trying to get you guys the basics about these cubes, not trying to get fancy. So, if you want, put in those original dots. So 3 dots there at the center. And then the 8, 2, and negative 8, negative 2. Take each of those dots and move them down 5. Now, for me, I could go 1, 2, 3, 4, 5. So now instead of being centered at 0, 0, I'm centered at 0, negative 5. From that point, I'm up 1 over 1 and down 1 over 1. And then from that point, we're also 8 and 2. And again, yes, arrows on both sides. Okay. Got it? One more type of problem. And I do believe you have some of these in homework. I don't know if anyone's checked homework out or not, but I do believe you have a couple of these. This is about rewriting a radical function so that, not that we're going to graph it, but we could graph it if we wanted to, because we're going to kind of dissect it into our transformations. You know, those stretches and shrinks, reflections, movements of left, right, up, down, our translations. We're going to dissect it. Now, if I ask you what the square root of 9x plus 18 looks like, I don't really expect you to know as you look at this form. Any thoughts about what you see underneath that square root, though? I would agree with going left 18 if it was just a plain x. Because of that 9x, we're not going to go left 18. We'll talk about how far left we're going in a little bit when we get there. What do you think, Carter? Okay, so under the radical, think GCF with me is where Carter's going, just not knowing what to say. What are 9x and 18 both divisible by? 9. So I'm not going to divide them. I'm going to factor the 9 because we don't want to just get rid of the 9. So let me rewrite this. It's still going to be under the square root, but under that square root, I'm going to factor out my GCF of 9. If I factor out GCF of 9, what remains in the parentheses? X plus 2. Because 9x divided by 9 is x, 18 divided by 9 is 2. I know we can call it a coincidence, or we cannot, but what do you know about 9? It's a perfect square. And because it's 9 times another factor, you can take the square root of 1 and not the other. So the square root of 9 is 3. Where am I going to put that 3? Outside. And so we can rewrite this as y equals 3 times the square root of x plus 2. Now, that is my rewrite. It said, how can you rewrite this using transformations? That's my rewrite. Now I would expect you to be able to look at this and tell me how to draw this graph. Do we still want to move left 18? No, we're going to move what? Left 2, and what else? Vertical stretch by a factor of 3. Now, good practice. What graph are we doing this to? What is our parent function, our basic graph? The square root of x, yes? So just, good forming there is that we need to talk about, okay, what graph are we talking about? What is our basic graph? So when we talk about this, this is going to be, when we describe it in words, the graph of y equals the square root of x stretched, I guess I should officially say stretched vertically by a factor of 3 and translated, because that's an official word there, translated left 2 units. So yes, I got wordy, and I will get this all on the screen for you momentarily if you'll give me a moment. But that's good, I know some of you guys try to be minimalist and just give me the basic words of left 2. I always appreciate more than left 2 that you tell me what we're doing left 2. Official word is translating it. Moving left 2, shifting left 2, those work. Okay? And it is stretched by a factor of 3. I can live with or without the vertical, but, good practice. And again, good practice to tell me what graph are we doing this to? Was this a square root, a cube root? Was this a parabola? What was this? Okay. One more? Of course, what's different about this one? It's a cube root. Okay, so starting under that radical, though, what do you notice inside the cube root? They can both divide by 8, which means we're going to factor a GCF of 8 out. So I'm still going to keep it under the radical. When I factor 8 out, I'm left with x plus 4. And the minus 2 outside of the radical is just tagging along for the ride. Coincidence or not, what do you know? 8 is a perfect cube. What is the cube root of 8? 2. So when I rewrite this, y equals, the cube root of 8 is now a 2 out front, times the cube root of x plus 4 minus 2. Okay. What graph are we talking about this time? Y equals the cube root of x, right? And what are we doing to this cube root of x? Stretching by 2. Left 4. Down 2. Okay, put it in words. The graph of y equals the cube root of x stretched vertically by factor of 2 and translated left 4 units and down 2 units. Okay, guys. Not written on here, but you know what your homework is, right? Lesson 6.8 in Math Excel. And you have 7 minutes. The iPads don't take long to log on to. You can get a little bit done. And I believe there's only 10 problems. Is that what I remember? Due Monday.